Imagine the cosmos as a grand stage where galaxies are the main characters in an epic play. Each galaxy, with its billions of stars, planets, and cosmic dust, is the result of a story that began over 13 billion years ago. Today, let's unwrap this cosmic tale and understand how galaxies, these vast islands of stars, are formed. The journey of galaxy formation starts with tiny fluctuations in the density of matter in the early universe, just after the Big Bang. Picture the early universe as a hot, dense soup of particles, mostly hydrogen and helium. Within this soup, there were slight irregularities. Some regions were denser than others. These denser regions had a stronger gravitational pull and began to attract surrounding material. As time passed, these small perturbations grew larger and larger under the relentless pull of gravity. This is the essence of gravitational collapse, a fundamental process in the formation of galaxies. Massive clouds of gas and dust were pulled together, growing hotter and denser as they collapsed. In these increasingly dense environments, something spectacular happened. The gas within these massive clouds began to cool and condense into smaller clumps. These are the seeds from which stars are born. The birth of stars is a key event in the life of a galaxy. As more and more stars formed, their collective gravity further pulled in gas and dust, helping the galaxy to grow in mass and size. Let's pause here and think about the different shapes and sizes of galaxies. The most commonly observed shapes are spiral, elliptical, and irregular. Each shape tells a different story of its environmental influences and formation process. Spiral galaxies, like our Milky Way, have distinct winding arms. These arms are sites of intense star formation and are often triggered by the galaxy's spin. As the galaxy rotates, the gravitational forces create waves in the gas and dust, which compress it and form new stars. The beautiful spirals are not just pretty, they are star-making factories. In contrast, elliptical galaxies are more rounded and less clearly defined. They generally form when galaxies collide and merge, a dramatic event that scrambles their stars and gas into a new elliptical shape. These mergers are not gentle processes. They are cosmic catastrophes that can trigger bursts of star formation, often consuming much of the galaxy's gas and leaving little material for new stars. Irregular galaxies, as the name suggests, lack a defined shape. They're often the product of gravitational interactions that distort their structure. These galaxies are particularly interesting because they highlight the dynamic and often violent nature of the universe. Let's also talk about the role of dark matter in galaxy formation. Although we can't see dark matter, it exerts a gravitational force and makes up about 85% of all mass in the universe. In galaxy formation, dark matter acts as a scaffold. It collapses under its own gravity to form dark matter halos, and these halos pull in regular matter, helping to form the galaxies we see today. Another fascinating aspect of galaxies is their ability to evolve and change over time. Galaxies can grow by forming new stars, but they can also grow through interactions with other galaxies. These interactions can be mild, like pulling and deforming each other's shapes, or extreme, like merging to form entirely new galaxies. Let's consider our own Milky Way as an example. Right now, it's slowly consuming the nearby Magellanic Clouds, smaller, irregular galaxies that are being pulled apart by the Milky Way's gravity. In about 4 billion years, astronomers predict that the Milky Way will collide with the Andromeda Galaxy, our larger neighbor. This event will likely result in the formation of a new, larger elliptical galaxy. In conclusion, the story of how galaxies are formed is a narrative of growth, interactions, and transformations. From tiny fluctuations in the early universe to the magnificent spiral and elliptical galaxies, each galaxy's journey speaks volumes about the forces at play in our evolving cosmos. This narrative not only helps us understand where galaxies come from, but also where they are headed and how they evolve over billions of years. As we continue to gaze up at the night sky, remember, each star, Each swirl of cosmic dust is part of a larger, awe-inspiring story of cosmic proportions.